All right, we're at 8 a.m., so I'm going to get started. I think there's still probably a few people filtering in, but okay, so hopefully my slides have popped up there. Can someone give me a nod if that's true? Yeah, great, thanks. All right, so welcome everyone. Thank you for coming, and yeah, welcome to this webinar panel discussion on best practices for observing air-sea carbon dioxide fluxes. We've got a great selection of panelists here covering a wide range of geography and different career stages and different observing platforms and measurement types. So I'm really excited about this. I just want to quickly thank the panelists and also the webinar organizers. So Krista, Megan, Juliet, Venkat, and Cassie have all been really helpful in helping to organize this session. I'm going to keep my comments now really brief, just a even less than 5-minute welcome. Here's the schedule for the day, for the session. So after me, Ralph Keeling is going to give a few introductory remarks. And we'll have quick panelist introductions after that, and then we'll go straight into the panel discussion. And then we'll reserve a few minutes at the end for audience questions. Please feel free to add questions in the chat at any point during the webinar. We'll either have a few sort of inserted into the discussion as we go along, or save a few for the end as well if we have time. A couple of admin things: the webinar is being recorded, and also I don't know exactly how everyone's screens look, but to help with the display for everyone, if audience members can please turn off their microphones and cameras, then that will help to keep the. I think if anyone has the option, there's a kind of a button near the top of my screen that says everyone by default, but if you switch that to active cameras and all the non-panelist people have their cameras off, then it will keep the panelists on display. And I think that's it. I think so. I will pass over to Ralph now, if that's okay.
Okay, thank you, Jack. Can everyone hear me okay? So I'm honored to be given this kickoff spot in your meeting. I hope I can inspire and shed light. I work on very large scales. I think on scales bigger than probably most of the people here, so my contribution may be a little off center, but I hope it's still important. So air-sea flux of CO2, why is it important? Well, the ocean is a sink of about 1/3 of anthropogenic emissions, and it's likely to, in the long run, store even more than that. And there are environmental consequences for the flux on the ocean that we care about. So it's a big part of climate and the CO2 problem. The approaches to measure the flux go back to first just trying to work out the ocean's contribution to global mass balance, which was done in the 60s and the 70s via constraints on ocean mixing and basic understanding of the chemistry. In the 1980s, I think particularly because of the pioneering work of Taro Takahashi, we started to have enough measurements of the CO2 partial pressure in the surface ocean to get a handle on the flux a different way. That led to a landmark and sort of a provocative paper, Tans et al., 1990, that argued that the Northern Hemisphere was a large sink. Northern Hemisphere land was a large sink for CO2, mainly because the oceans didn't seem to be able to account for the hemispheric balance. And so that also illustrates another reason these measurements are important, is that they allow you to work out what the land is doing. And I should say that the carbon community now is overwhelmingly populated by terrestrial ecologists and people working on land fluxes because of the land surface being something that countries own and therefore have a stake in. It's not part of an international commons. It's a big term in the budget and there's room for mitigation. The ocean is in a somewhat different status because it is a commons. So most of the work that would be done is for advancing knowledge rather than advancing political agendas. But anyway, the ocean plays a role in that as well. Now, as far as best practices for measuring fluxes today, there's been a lot of progress, I'm sure, in the last decade that I'm not up to speed on, but a couple comments. One is that the approaches that I'm aware of for measuring fluxes are distributed among different space and time scales. You can do eddy flux measurements that are very local in space and time. You can do estimates of fluxes based on bulk parameterization and PCO2 measurements, which typically will have to be averaged over some time scales to be relevant. There are constraints coming from the atmosphere that allow you to infer fluxes by inversions on much larger time scales. And I would say all of these methods, and I guess you could also look at the mass balance within the ocean to infer what the flux in another water would have been. That's important, I should say that too. All of these approaches, they're on different space and time scales, and they all depend to some extent on a conceptual model for what's happening, and those models are incomplete. So, and possibly seriously incomplete in some cases. And how do we know that we're measuring the right thing? Well, you do it more than one way. So this is still a field of research as far as I'm aware, and as much as the society needs this community to deliver products, I think one also has to recognize that this is still an area of ongoing research and progress. And this is my the political soapbox, it would be unwise to too seriously consolidate around one preferred approach, because as I said, all approaches are based on conceptual models. It's really not possible to calibrate a flux measurement in the same way it is possible to calibrate a PCO2 measurement. And so the way you overcome that is you have multiple approaches, and when they show convergence, then you have confidence. So I hope that what comes out of this meeting is an understanding of how to work together to come up with a better synthesis rather than necessarily a single preferred approach for making the measurements. I thought I'd just show one slide if I can. I've been working at various scales, and I think this is an exciting development and may be worth noting. Can people see this slide? Can people see a slide? No, okay.
Not now.
Okay, well, maybe I'm not going to figure it out in this time frame. People
It
can
showed up
see.
now.
It's there. It's there.
Oh, it is there. Okay, so this is a slide showing the flux of CO2 in and out of the Southern Ocean in a sort of seasonal climatology in different bands, and the bands are not exactly latitude bands, but they're demarked down here. Can people see my cursor? Yeah. So these are different data points, and this method involves airborne measurements. So this was part of 2 airborne campaigns, ORCAS, well, 3 really, ORCAS, HIPPO, and ATOM, where CO2 analyzers were flown on an airplane, and this allowed resolving concentration gradients of the order of a few tenths of a part per million. The atmosphere in the Southern Hemisphere is nicely organized to resolve fluxes across latitude bands because the atmosphere mixes rapidly around the circle, not across. This can be compared with measurements made with floats. It can be measured with ocean models. It's still a work in progress, but it's extremely powerful what we're able to do here, because we're actually resolving on a finer scale than people have been able to do with other methods, just because of the difficulty of sparse coverage. So I would point out that another approach that I think is very promising is to fly CO2 measurements in the air over the water. There's a lot of power for that, even at these very large scales. Okay, so I'll stop there and hand it off. I assume I've gone my 5 minutes or so. So I've looked forward very much to hearing what else comes out of this. So thank you. And I have to figure out how to stop sharing here. How do I stop share?
Thanks, Ralph, for that. Really fascinating stuff. So let's quickly, I just want to actually, before we move on, mention one thing. This webinar has been organized by the OASIS Best Practices and Interoperability Experiments theme team, one of 5 theme teams in OASIS. And yeah, we're kind of focusing on the best practices, but it's also really great to hear from Ralph the interoperability ideas coming through as well. So I think that's an important part of this. So I'll now hand over to the panelists to do quick introductions for each of them. So let's start with Adrienne.
Hi, I'm Adrienne Sutton. I'm an oceanographer at NOAA's Pacific Marine Environmental Lab in Seattle in the US, and glad to be here. Thanks.
Thanks, Adrienne. And now Arne.
Hello, everyone. My name is Arne Körtzinger. I'm professor for marine chemistry at the GEOMAR Helmholtz Center for Ocean Research, which happens to be in the north of Germany. And I've been looking at the marine carbon cycle ever since my PhD work, and that's 30 years ago.
Thanks, Arne. And now Dariia.
Hi, everyone. Thanks for tuning in, and thanks for inviting me today. My name is Dariia Atamanchuk. I'm a research scientist at Dalhousie University, Halifax, Canada, Eastern Canada, just to orient yourselves. And I'm also looking at the carbonate cycle and air-sea exchange of gases since the start of my career. And I'm particularly involved in the observation of air-sea fluxes.
Thank you. And Warren.
Hi, everybody. My name is Warren Joubert. I'm a researcher at the Global Atmosphere Watch Station in South Africa. We monitor long-term greenhouse gases in the atmosphere as part of a network, part of a global network of doing these measurements. My background is in oceanography, focusing on air-sea fluxes between the atmosphere and the ocean. Yeah, so in a nutshell, that's me.
All right, thanks everyone. And Ralph, I'm going to kick it back to you to open with the questions. You're muted right now, Ralph.
Yes. Hello. Sorry, I had to disappear in order to stop my screen there. So I missed the thread here exactly. So I'm asking, maybe I'm not the right person to do this at this moment. I have to be honest. So I'm a little unsure of the context here in every sense. So,
so you want me to ask the questions then? If you're, yeah, I'll go ahead and do that.
Yeah,
if that's what you mean. Are you having? You're okay,
yeah. Technical
wise too. Okay. All right. Well, the first one. Let's start with Adrienne answering this question. And so in the field of CO2 fluxes, air-sea CO2 fluxes, what are the biggest measurement uncertainties? Where are the uncertainties in this field?
Yeah, lots. And I guess I just want to build on one thing that Ralph mentioned, is that, yeah, there are various approaches for getting at air-sea CO2 flux. And the one that I have the most familiarity with is calculating CO2 flux from measurements of air and seawater CO2 and wind speed. So, you know, not direct measurements of CO2 flux, but the bulk parameterization approach that Ralph mentioned. So I can speak to that. And I guess first I would say that we need a framework to regularly evaluate and evolve best practices. We don't really have that right now. And so developing that framework is currently being led by IOCCP, the International Ocean Carbon Coordination Project, and the G7 Future of the Seas and Oceans Initiative. So that's good news. We will have a framework for that. In terms of the seawater CO2 measurements itself, I guess I would just say that one of the most common approaches is to use an infrared detector that was designed for other purposes, like for measuring high CO2 levels in HVAC systems. But one of the challenges is that R&D efforts focused that we need R&D efforts really focused on the specifications that the ocean CO2 community really needs. But there's often not a lot of funding for developing that, and that's, you know, not a problem just within this field, but that's a problem throughout ocean observing. I would also say that, you know, there is a push to standardize some of the most commonly used ocean CO2 instruments and their operation. Right now, there are a lot of custom-built systems that a handful of people can operate, and that's really not sustainable in the long term. So that framework will help that. Yeah, and I guess I'll stop there. Let someone else chime in.
Yeah, Arne, do you want to add something there?
Yeah, sure. Why not? So I like Adrienne, I've been doing these PCO2 measurements for a long time, and I think, given the big picture, we've come a long way, I think, with developing the technologies and maturing the systems that we're using. So I think from my view, this is not necessarily one of the most critical areas, the measurement of the PCO2 itself. You can do everything wrong about it, and even systems we know usually perform well could in any given case perform not so well. We know all that, but we have the recipes, I think, to do very good PCO2 measurements, actually from various platforms. So, and then I would know that Krista Morandino would throw in the aspect that we don't know the transfer coefficient for CO2 well enough, and that's probably also a well-taken point. But also there, my feeling is this is not the weakest thing in everything. It has uncertainty, but it's perhaps not the weakest thing. My view, the weakest thing is our spatial and seasonal coverage of the entirety of the ocean, not just the Southern Ocean, coastal oceans, upwelling regions with high seasonal and interannual variability, subpolar North Atlantic. There are areas that we cover well with the Shippers Opportunity Network, like the North Pacific and arguably the North Atlantic, but there are areas we will never be able to cover well. And I think a significant fraction of the uncertainty comes from us not being able to do a uniform, not even a far away from a synoptic view of the ocean in its entirety. And that's the point I want to throw in here now.
Thanks for that. Dariia or Warren, do you have anything to?
Yeah, just to add what both Adrienne and Arne was saying is that I think I agree 100% is the idea of the fact that the parameterization of the gas exchange between the atmosphere and the ocean is probably the biggest challenge from a measurement uncertainty point of view, but then also our spatial coverage. Not sampling everywhere all the time type of thing, and we can't because it's just too expensive. I do think though that because those two concerns regarding the uncertainty of our measurements is probably where we want to put our effort. There are things coming along, but they're spinning up slowly in a sense, whereby we're starting to use these autonomous platforms to try and be able to close that gap from an observational measurement point of view. And so we are trying to close that gap, but I do still think that the biggest uncertainty is associated with parameterizing the exchange between the atmosphere, and then also where we're measuring not having data in some areas. Thank you.
And I would just like to add to what Warren, Arne, and Adrienne said in that respect. Another huge error we get is when you calculate the fluxes using parameterization model, measurement of PCO2 and wind speed. And there's another, I think, overlooked area where we think we know the best, but if you compare the wind speed products from the all available platforms, you will have a really high disagreement, especially when it matters the most. The regions of high winds are usually parameterized as the regions of the largest uptake or the largest outgassing. So if we don't get those wind parameterization right, sort of wind speed product right, we don't get the airspeed flux right, if we use, again, the measurements of PCO2 to calculate it. Another point I'd like to mention and add is with respect to PCO2 measurement. I agree with Arne that I think we are getting close to measuring PCO2 really well. The question is, are we measuring it in the right spot? I think there is an uncertainty associated with the fact that most of the intakes in the underway systems are sitting somewhere at 2, 3, 4, 5, 8 meter depths, and we would always assume that this is representative of the boundary conditions, which is not true. So, and that's been shown in numerous modeling studies and also observations. So again, measuring it in the right spot of the water column, right at the interface, can be beneficial if you want to narrow down the flux in that way. But also, again, agreeing with Arne's opinion on there's regions of the global ocean where we cannot measure PCO2 because of seasonality or other factors. And that would mean that we'll have to rely on other methods like, you know, modeling interior ocean and calculating flux based on that. And that's where we do not have enough measurements too. So again, measuring PCO2 at the surface, but also having an understanding what's happening in the water column that drives this flux is also one of the gaps that we should address if we're to you know, narrow down the uncertainty in the RC fluxes around the global ocean.
Well, thank you. Yeah, I think everyone has actually already kind of started answering my second question too, which was going to be how the uncertainties related to the kind of big picture science questions. And so, Ralph, maybe you have something to add on this, given your kind of introductory comments. But everyone's kind of mentioned this, the link between the small scale measurements and the big picture global fluxes is.
Yeah, good. I'll bring up a point that hasn't come up yet. And that has to do with what you actually want to, what you want the end product to be. And from the standpoint of atmospheric mass balance and the controls on the buildup of CO2 in the atmosphere, what you want to know is how much extra carbon is accumulating in the ocean relative to before from atmospheric origin. And there's two paths for carbon to move from the atmosphere into the ocean. One is via the air-sea flux and one is via rivers. The river has a natural component. There's a natural loop with the carbon flowing off the land into rivers, into the ocean, and back out into the atmosphere. And I've contributed, along with others, to some estimates of this global air-sea, global river flux, and it's certainly the order of half a petagram carbon per year. So it's big, and it's big enough and troublesome enough that it's not obvious that integrating the air-sea flux over the surface of the ocean is really tackling what we want here most. At least it has to be combined with the river effect. On the other hand, there's really no better approach for getting at some aspects of space-time variability than looking at PCO2 and working out how it's varying. So I would point out that, you know, what is the end game here? Is it trying to get the global flux, or is it trying to contribute to understanding by filling in some space-time niches that are not otherwise addressed well? And I would say at this point, it's the latter. That doesn't diminish its importance in any significant degree because it's still fundamental to understanding all sorts of issues like feedbacks and controls and mechanisms. But where you're targeting the science also affects what you think is the most important areas for refinement. And I don't have the answer to that, but I point out it's a real issue for how to frame this community's efforts.
Thanks, Ralph. I wonder if the question in the chat from Rachel Cave about CO2 fluxes in nearshore waters kind of maybe is part of that question too. I don't know if anyone has any thoughts on that at this point. Kind of the idea that the nearshore waters might be as kind of a disproportionate contribution to fluxes. So, if
I can take on that if you don't mind. I will start with. Where do I start? I start with you know, in in what Ralph just said about what is our end game, and then I think as a part of IOCCP, that question that we sort of came to when we started thinking about this framework that Adrienne was referring to, it is, do we really need to measure ARC flux, or we need to understand the ARC flux? These are two different questions, require two different solutions, and the coastal oceans are part of the problem. We are making these assumptions that all the continental shelves experience upwelling, brings DSC high water, cause outgassing. From the recent study here in the Scotian Shelf in Eastern Canada, we showed that that's not the case. Yes, upwelling is happening, but it has the water characteristic that actually drives the flux the other direction. So to frame my answering in this way, yes, we need to focus on coastal regions more and more, just because they're so dynamic, but also need to study them more because not all continental shelves are the same. And then the answer how we do it, of course, again, we need to do measurements, and to do measurements we need to I would think, reevaluate how we collect the data and the platforms that we use for the collection. So we'll have to rely more on solutions that would be easily adaptable for coastal observations. It means different sensors and platforms. Introducing new sensors and platforms brings the question of the need of intercomparison exercise, where you introduce the new platform that is already, compared and its quality and performance is assessed. So, yeah, I mean, the coastal areas are important, and we need to do it, and we need to do measurements, but these measurements cannot be done with the platforms that are currently used in the open ocean, like underway systems. So we need different platforms, and different platforms means more sensor development, more platform development to fill in this particular gap.
Does anyone have anything to add on this before we move on?
I'll just add one quick thing that, if we really want to measure the coastal zone, we're going to need more accessible technology, because, it's right now you need to be a super expert to run these things, and, we're not going to get great coverage if we're using our current technology to do it.
All right, thanks, everyone. I think I'm going to move on to the next question of how close are we to best practices for CO2 flux measurements, and the stages I could see in this are kind of documented standards versus an informal consensus versus everyone doing their own thing. And this maybe can kind of also loop into that question of intercomparing different platforms and so on. So maybe, Adrienne, do you want to jump straight back into that one, particularly based on your answers earlier on about some different efforts that were addressing best practices? Or
sure. I can start off. So yeah, in terms of surface seawater CO2 best practices, I think we have some. Actually, the three categories that you mentioned, I would say all of the above. It's kind of a mix. There is a guide to best practices for ocean CO2 measurements that Andrew Dixon and others published in 2007 that describes the equilibration-based method that a lot of us on the panel use for measuring seawater CO2. But there are a lot of different versions of instruments that utilize that method. And so through the process of developing the data product called the Surface Ocean CO2 Atlas, or SOCAT, some additional standards were set to better determine what the data quality is from all of those different instruments. So if you're submitting data to SOCAT, there are some standards that need to be documented. I guess, yeah, and I guess just to mention one more thing that Dariia brought up, PCO2 instrument intercomparison is a priority of the community and has not been done as often as we wanted to do it, but one was completed last year. So there was a very recent intercomparison exercise between all of these different instruments. So yeah, I guess I'll start there. Put to others.
Thanks. Yeah, and Arne, did you want to add something there?
Not really, because I think I would have exactly mentioned the same thing. I think the ICOS SOCAT community has really developed a lot of progress in how we do the measurements, which rules we apply to, and what are the minimum requirements for something, get a certain flag, a high quality flag, and so on. And the community is being educated to go that way. Also, the recent comparison on PCO2 systems, which not just the classical benchtop instruments that have these equilibrator, gas water equilibrators, but also the entire zoo of existing and emerging submersible or flow-through PCO2 sensors which have membrane separation and other things. I think they are particularly looked at more recently, and that's important as we want to embrace other platforms. We need to be clear about which sensor technology gets us at least close to what the gas equilibrator-based systems can achieve. So I think we're on a steep learning curve. Then I think once the lessons are obvious that we learn from this, I think we've done another step. So I think it's underway. You're never there, but I think it's in a good direction moving ahead.
Thanks. Yeah.
If I might just add, since we're talking about intercomparison, I think it's also vitally important to have the intercomparison not only the PCO2 instrument within this area where we calculate fluxes, but in intercomparison of methods to calculate or measure fluxes, whether it's eddy covariance or the ocean bulk method or the calculating from PCO2. These have to be compared too, because most often they do give conflicting results. So we need to reconcile this difference or try to find out where the difference coming from, and that would be beneficial for everyone. By the goal of intercomparison is not only to assess whether one method is good or the other is bad, or one instrument is good and other bad. Is most importantly, it is done to find weaknesses in one method or the other. By finding the differences, we critically look at the methods and reevaluate them and hopefully bring them to a better place.
Just a comment that I would like to add to what the panel is already saying. It's very focused on the observations or the uncertainty associated with the observations that we are making. But I think several groups have, and this is now slightly, maybe I'm going off a little bit, but several groups have tried to compare models and use to sort of increase the data availability or do interpolation mechanisms and compared different interpolation schemes with each other in order to try and see where our limit is in terms of by how much we can reduce the uncertainties. And I mean, even those things run into the same problems that we have from a data availability point of view, that where there are no data, that's basically where the uncertainty remains the worst. So yeah, just a comment.
Well, thanks for that, Warren. My next question is, I mean, I kind of hope is going to build on this, and who are the best practices for? Really, is the, you know, what is the what is the aim of these different best practice kind of systems and guides? So, Warren, you start off.
Let me start. I don't know. Everybody can add. I might as well. So obviously, I think one of the first things, it's for the community who are doing these reaches, this research on fluxes. You know, I mean, if there are new people that are being added to the community, you know, where do you start considering? You have to have some sort of idea of what is currently the sort of best available practices to actually do in order for us to start improving our understanding of these fluxes. And yeah, to sort of have that comparing apples with apples idea, you know, there's no use in people, you know, obviously it's a good idea to have as many different approaches as possible, but how well do those different approaches compare with each other? I think that's an important thing. So I think it's for the community, in a sense, to really constrain appropriately what we mean when we say the flux of CO2 is this at a certain time. So yeah.
Arne, were you going to add something there?
I think, of course, the users themselves are the first group that these best practices are for. But I think for manufacturers or people that are trying to develop, bringing new technology into the field, I think it's important to know what are the expectations, requirements that come with the different platforms. And if we, in most cases, we can define them well, be it in terms of climate and weather goals, standards, but we can provide guidance to manufacturers, and I think that is needed because they have to have some target that doesn't, you know, move around all the time, but is reasonably robust over time so that they can really try to develop things up to these targets that we define for them.
I guess I have a question related to this, if I could, since I'm outside the community. And it seems like the best practice discussion mostly focuses on how to do a good measurement of PCO2 in the water here. And my question is, what obligation do participants have to also provide information on the air-sea flux parameterization that applies at that moment in time when you're making the measurement? Is there a responsibility to also measure wind speed or surface roughness or any of these parameters? Is there any such obligation? And if not, isn't that a problem?
Yeah, I would say it is a problem, and there has been a conversation going around about how can the ocean CO2 community better collect high quality atmospheric data that would benefit the atmospheric community as well. So that is one piece that is missing. And yeah, wind speed is definitely another one. I mean, you know, other panelists mentioned the you know, the methods that take all of these sparse observations and interpolate them into a, you know, global map. And you know, how important that intercomparison exercise has been between all of those, because, you know, there does have to be some agreement on what wind product you use for that in order to compare, you know, across all of those, because they do vary quite a bit. But yeah, I would say for atmospheric CO2, that discussion has started, and for wind speed, probably not so much.
Maybe the wind speed question is going to be something for our next webinar on direct covariance fluxes, that kind of, yeah.
I guess I would ask, is wind speed itself enough?
I guess, Ralph, you know the answer. That's why he's asking us. Yeah, indeed, especially the recent studies showing that, you know, the white cap coverage and the surfactants, they play an enormous role in driving the flux. So I guess at some point we'll need to reconcile those differences too. What are the regions where those are being the most important? Yeah, I would think again about the coastal regions, for example. But at the same time, I'd also agree that you know, something like white cap coverage, you know, breaking waves and everything, that's something that can be done from space, and that sort of brings us to this, I would say, a global approach where, or start with a global approach where maybe instead of measuring wind speed or getting the wind speed and PCO2 in every point of time, maybe we can get by with using climatology and space pictures of white cap coverage, and that will bring us some more information than we get only from measuring single underway system lines. So yeah, we definitely need more studies on the effects of those, but at the end we'll have to, you know, again, reevaluate the best practices here with respect to the fluxes now, not the measurements, but fluxes.
Yeah, I think that can lead to my next question, which was going to be, can one set of best practices cover all different scenarios? But maybe the more relevant question is, you know, extending from best practices for individual measurement types to best practices for fluxes in general. How, you know, how do we, is that possible? And if so, how do we get to that point? So, Warren, do you want
to? So whether or not it's possible, I'm not sure I want to venture into directly into that. But what I do like to say is that that I do think in some instances we, you know, from measuring CO2 point of view, we're a little bit more advanced. But then when it comes to the observations associated with the gas exchange parameterization and trying to constrain that, we haven't necessarily put the same amount of effort, I would say. I think there are people looking at it, but I don't think we necessarily put the same amount of effort into trying to constrain that in the same way that we are doing with the CO2 measurements. So perhaps if one thinks about it in terms of trying to formulate best practices for the entire, you know, then we need to put a little bit of effort, not necessarily, you know, put an effort where it's required in a sense, for particularly, I mean, I really like Daria's comment about, you know, starting at a global scale, looking at you know, sort of just climatologically, and that being sort of the first step in terms of just coming up with a sort of agreed upon first approximation. Then as the need grows, one can then try and scale that down, try and look a lot closer at what exactly is happening at the ocean surface. I mean, the point that, again, Dariia made earlier about the fact that the ship's intakes are at different heights, then you have temperature effects, skin effects happening right at the surface of the ocean. I think all of those things, to some extent, I don't want to say we neglect, but we don't put the priority, we don't equalize the priorities when it comes to looking at all of those things. So perhaps from answering the standardized best practices point of view, we might have to start thinking about really putting effort into where the needs actually are for those specific things. Thanks.
Thanks, Warren. We've had this kind of discussion on the idea of decision trees in the best practices theme team a little bit. I don't. Does anyone have kind of thoughts on that concept? Is that something that can cover these questions, or is there just too much variety in what needs to be covered in such a, simplified kind of framework? Does anyone have any thoughts on that?
I've thought about, sorry, go ahead, Dariia. I'll be quick. I've thought about decision trees in the context of best practices for data quality control. I think those can be really, really useful, especially for people that need a little capacity building related to data QC. So that's one area that I've thought about decision trees.
And I just wanted to add that all these decision trees and whatever we are doing should be guided by this principle that I think Andrew Dixon been introduced. I really like it. It's called fit for purpose. What are we looking? What are the questions we are looking to answer? Maybe indeed for our global estimate of the carbon uptake by the ocean, it's enough to use climatology and some rough estimates of wind speed. But if we want to understand the local processes, local circulation, the local scale, then perhaps we need a different tools. So it doesn't mean that they are, good or bad. We need to make sure that they're fit for purpose. So they answer the questions that we are asking.
I thought I'd bring up, I guess, a way to frame the decision tree on what kind of space-time coverage you need, because that's come up. And how do you decide how much is enough? And it must hinge in part on the degree of persistence of PCO2 as a variable in space and time as to how much coverage you actually need. And I just wonder, and I think this is probably especially critical when one moves from the open ocean into the coastal realm, where I suspect the persistence of PCO2 is much less in both space and time. So I think it would be an interesting target to try to get, I don't know if people have published on some kind of persistence measure like that, but just to inform this community, just to have maps of persistence, maybe even as coming from models, to get some idea of what kind of space-time coverage you need, because it may be without that, you're kind of, everyone is on their own trying to guess what they need, and maybe there's a way to have a community product that helps people decide what kind of coverage they need, or they can make measurements and use it as part of a decision tree to expand or not expand their coverage. It's a cross-cutting issue here, but it's something I haven't heard about too much. I know people have worked on it at different points in this community's history, but I don't know whether it's still on the agenda.
If anyone was going to respond to that, then I'll let you do that. But otherwise, I'm going to move us on to audience questions. Were you going to say something, Arne? No. Okay, let's. We've got quite a few audience questions. So I was going to, if Jamie Poulter is still there, do you want to unmute and ask that really interesting question you had?
Oh, thanks. Yeah, sure. I kind of just wanted general reflections on how all of these things change when we're going to be increasingly asked to deal with MRV, measurement, reporting, and verification of ocean uptake in the context of manipulations of ocean uptake for ocean carbon dioxide removal, which I think is heading towards us like a freight train, something to figure out. Thanks.
Thanks, Jamie, for the question. I know where you're coming from on this. Yes, you're right. In order for us to assess, the effects of this possible either alkalinity enhancement or iron fertilization or et cetera, we need to have a solid baseline. What are the natural fluxes, and how do we compare them with the effect of alkalinization or nutrient enrichment? So again, we're coming back to the coastal regions because those are the ones that or will be initially chosen for these pilot experiments on fertilization and alkalinity enhancement. So, and to my best knowledge, there is, even within the on local scale and on regional scale, there is very little knowledge about the fluxes, ARC fluxes of carbon dioxide. So, and that's primarily driven by inaccessibility of the technology, I would say. I think someone mentioned in the comments that, you know, the gold standard PCO2 system is costing almost $150,000, and that's, you know, for some research groups, it's just not something that they can throw money into. So that sort of brings us back, you know, in the circle to the need of improving the sensor technology, making it more accessible, simpler at least, and that can be easily operated on a regional scale in a quest to collect these vital background data on the coastal ecosystems.
Yeah, and I would just add that there are two scales at which we need to think about with regards to carbon dioxide removal. Is that if it's an ocean-based approach, yeah, we have that local scale that we have to constrain and understand whether, you know, the approach is working and what kind of impacts it has. But eventually, if CDR approaches do actually get implemented at scale, we're also going to have the global scale to understand too. And how is the ocean uptake changing, right, as we're implementing these mitigation approaches? So we have, yeah, two different scales there that will be challenging.
Maybe this is a good point to bring in something into the discussion, which I think is possibly could be a game changer, and that not just is important in the context of carbon dioxide removal techniques, but also refers to a to a comment Ralph made earlier on. It would be very, very useful to connect whatever CO2 flux we see at the surface to interior ocean storage changes, because we will not just be passive uptake of anthropogenic CO2. We will be reorganizations in the productivity and the remineralization length scale and so on in the ocean that cause significant changes in the natural carbon component. And we need to understand the causes of whatever CO2 flux changes we see at the surface. So we have to have the third dimension. And this will never be possible, of course, with the surface ocean CO2 network. But the biogeochemical Argo program that is emerging and will, I think, take place has the potential. I'm not saying it's yet there, but it has the potential to provide that third dimension and allow us to connect what we see at the surface with the interior ocean and look at the storage term. I think the surface ocean CO2 network, observation network, is far ahead in terms of quality of the measurements, and biogeochemical Argo is just now still only restricted to pH measurements, and even those are not necessarily up to the level we want them. Even there are possible systematic problems. But I have the feeling that when we can solve this, and we will eventually be able to solve this, we need to pay attention to connecting this emerging float-based observatory in the most clever way to the surface observations, so that we can have a seamless observatory that gives both a synoptic surface and deep ocean view. And then things like natural carbon cycle changes, but also CDR techniques applied at a larger scale will all be approachable with that technology.
Thanks, everyone. That's really interesting discussion on that. I wanted to move to Nicholas, if you're still there. Your question maybe it was partially answered already, but that kind of gold standard instrument question. Nicholas, are you still there? Do you want to raise anything further on that?
Thanks. I feel like my question was partially answered by Dariia and by Pauline in the chat. But if anyone else has other insight.
I just in terms of the instrument accessibility, I think this is something that we need to tackle within, you know, the ocean decade timeframe, right? If we're going to fill data gaps in the Southern Hemisphere, we need, you know, we need more accessible technology, and, you know, we need capacity building. And I don't think that's something that this community has really thought a whole lot about. So I would just, yeah, add that to that topic.
Okay, thank you. Yeah. Well, I think we are nearly at the end of the hour, so I just wanted to, first of all, say thank you to everyone, panelists and audience, and then just kind of ask if anyone has any of the panelists have any final thoughts. You know, last 1 minute of.
I'll just expand quickly on, that's okay, quickly on something that Arne said, and I agree with his point about the third dimension and connecting with ocean interior, but you could take it a step further and say that what we really need is an assimilation system that brings together surface water, deep water, knowledge of ocean currents and circulation, as well as atmospheric measurements, and we simply don't have that. And it's computationally daunting, and it's not for this community. But I'd make my guess is it will happen, and in the context of, you know, enhanced ocean alkalinity enhancement and these kinds of problems, we absolutely need it. And in the context of such an assimilation system, maybe PCO2 at the surface, even independent of air sea flux measurement, is itself a valuable contribution. So one could point out that PCO2 is an important parameter of seawater, and having a map of that, whether or not you can directly translate it to flux, might help you get flux through an assimilation system.
Any other last thoughts? No? Last chance. Okay, well, yeah. I think that that data assimilation idea, I guess, is another another reason to kind of really have a, you know, widely adopted best practice, right? If you need those kind of uncertainty estimates in that context, that's an important part of that equation, I guess. And so I think if we are all finished for now, then I want to say thank you again to the panelists. Let's do a virtual round of applause for them. And thank you all. Yeah. All right. And then.
And thank you, Jack, for standing in.
Pleasure. Yeah. Lots of thumbs ups and rounds of applause. So yeah. Thanks, everyone. And have a good rest of your day. Bye-bye.
Nice seeing everyone. Take care.
Yeah.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.